Hello friends! Sorry I haven't been around in a while. I've had other projects that I've been working on, larger projects. But anyway, here we have an Amiga 1200 that's owned by my friend Brad. I've had many stuff on my channel from him. This one, however, is a little bit different. He accidentally broke it and then he attempted a repair and it didn't go very well. So I'm not going to be criticizing too much because we all make mistakes. So the result of Brad's attempt to fix his Amiga 1200 is actually quite horrific. Viewer discretion is advised. What he did was he accidentally dropped it and it broke the PCMCIA slot. So he bought another one and he attempted to remove the old one, and it's pretty much carnage. But again, I don't find fault with people trying stuff. I believe this is a repairable thing for me, so no harm, no foul. You know, we all make mistakes. I mean, I made a mistake when I asked the Hulk and his brother to help me move. So anyway, let's take a look at this thing. All the screws have conveniently already been removed. So here we have, prepare yourself. It's ugly. So he did get some of the pins out, but others are remaining and twisted around each other. And something you wouldn't want to do is turn this on right now. That is the last thing that you want to do. Turned off and everything. Okay, video, power. I hooked up this so that I could see immediately if we have a light on. And here we go. 3, 2, 1.
Just kidding.
The general appearance of the surrounding items and everything is just his attempt at trying to remove the pins using lots and lots of flux, which unfortunately only resulted in kind of making a mess. And then when he brought it over, I pointed out to him, he didn't realize this, but he's got a capacitor that has broken off here. So I'm hoping it looks worse than it is. We have, you know, this is one of those things where I'm not 100% sure. I think I told him 50-50, which is a little bit pessimistic as far as fixing this. I like to set people's expectations low. You know, let's just fix this up. The one thing that is troublesome is the fact that I don't know how well you can see this, but there are what I believe to be broken traces. Alright, well, I'm going to start working on this and getting it out. I'll film some of it. I'll certainly do a fast forward and we'll see how far we get. Once I get most of this mess cleaned, once I get all of this mess cleaned out, we'll take a closer look and see what actual traces are broken. So, anyway. Alright. I think what's really screwing me up and what's taking a long time is the fact that there's, there's these little metal pieces sticking up on all these, and I think that they're more trouble than they're worth. You would think it would make it easy to grab something and use it to pull out, but that's not actually the technique I'm using. I'm just using my desoldering gun to suck it out. I think what I'm going to do is I'm going to cut these guys real short and then go to the other side, because I've started to desolder the first few, and where they were cut almost flush, the soldering gun would just suck the solder and what's left of the pin in. But if the pieces are like bent over or too long, they're just working against me, even the fact that they're kind of soaking in some of the heat from the soldering iron. So that's the technique I'm going to use. So I'm going to get my side cutters and trim these all back. Okay, so now we get a good idea of the carnage. Yeah, we can see that we have all our holes cleared. So we have obviously some areas of some deep scratches, and they go across traces. So there are 3 traces here that are all broken. There are 3 traces here that are broken. So whatever these 3 traces are going over here, they're broken in multiple places. So at least it's obvious where, there's no problem seeing what's broken here and what needs to be fixed. So that's good. So check for missing pads. This one, I don't know where it goes. It just comes into a big scratch, and yeah, who knows where it goes from there. Maybe it goes to this pad here. But I think I need to, yeah. So it's not real bad. And we've got another broken trace right here. So that one just comes from here over to there. And this looks like that's going to be a pad, that's going to be a trace that's broken, but it looks like it's been shorted or something across here. So we're going to have to, there we go. So lots of bodge wires to fix this, I guess. So we got something in the neighborhood of 8 broken traces in various places. So and we also have that capacitor. While I was working, that capacitor fell off. So that capacitor is a 47 microfarad. Well, I think the very next step after cleaning that up that any normal person would do would be to check continuity. I have a laptop here where I've brought up Amiga PCB Explorer. The website there is amigapcb.org, and this is, according to what it's written over here, this is a Rev 1D A1200, so I brought that up. So we're just going to check this one, and then we're going to check this one, and then we're going to check this one, and then, hi cat, I'm going to check this one, and any others that I see are damaged. But that's the order. I'm just going to go from this side down. We got scratches across, like 3 scratches across. It's quite clear that some of the traces are broken. We're just going to confirm that now. Let me set it back up here. Okay, so that first one I highlighted. That one, oh, I didn't notice. That one actually goes underneath. It goes underneath this chip to the other side of the board. Just going to test. See, it doesn't, there's a scratch here, and it looks like the trace was scratched right here. Yeah, I can see the trace. Yeah, there's a piece of it right there. So this via doesn't go anywhere. It certainly doesn't make it over there, so we can tell that without having to hunt that one down. I believe all these are going to be bad. So the second one is CC reg from the memory card. It's right here. It's the 4th one up. 1, 2, 3, 4 in the middle. Yep, right here. And you know, it's here, but it doesn't make it any farther. There's a trace right here, and it just stops, and you don't see it going anywhere. And it goes up to a via that I can't even see it anymore. I guess I should inspect. There is one here that goes over here. That might be gone right there. Let's see. Oh, bummer, it is too. So that trace is broken right there. This one here is on the pin 8 or whatever. So that one's okay. And this one here, the one right below it, is pin 48. What? Oh, pin 48 of the memory card, which is pin 7. Okay. Which one are we on? This one? Yeah, that one's good. What's this? Is this more stuff over here that's bad? Oh, brother. So yay, that one's no good. And this one? Right next to it? Lines up right next to it up there. And it's not good either. So he ruined the traces here too. Yeah, I can see that these are broken. So there's 4 broken traces here. So here we are at my workbench, and I just wanted to point something out. I've started to do the repairs, and you can see that you don't see any bodge wires. Now, I have to try to get all the bodge wires on the back side of the motherboard, because I can't put any wires under here and then put the connector on and expect them to be 100% reliable. Every time this gentleman is going to be putting a compact flash card in here, and he uses the heck out of it from what I understand, it's going to cause a problem. You know, we don't want to have wires across here that he might catch. We don't want to have the connector pushing on the wires. We just want to have everything on the back side. So, and then the other concern we have is we don't want to put the connector on before we do our bodge wires. And some of our bodge wires are going to terminate onto some of the pins here. So that means I have to run the bodge wires and connect one side and then just kind of let them hang out in close to where they're going to go to be soldered when I install the connector. I'll show you that right now because I've done quite a few actually. Okay, so here we have the back side of the connector and a bunch of bodge wires that I have done already. And not all of the traces are actually concerned with the connector. In fact, there's a video sync trace that would definitely cause the computer to not output anything that I have repaired. So what we have here is we have a couple of these. I don't know if you can see this. I'm going to point to it right here. We have a couple of these that are I've ran, and they're just kind of, I've used Kapton tape to hold them in places to where I want them to go, and you know, to await the time when I actually install the connector, and then I can solder them in. I can't solder them in now because it's going to block the through hole, and I won't be able to get the connector in. So obviously things have to be done in a particular order. Here's another one here. And you know, you can always pick one side or the other to do your bodge wires as long as you have some vias that you can go through. So here's a via right here in a ground plane, and because I'm using this magnet wire, I'm able to run through such a small, I mean this is hair thin, it's technically 30 AWG, but anyway, this is the beauty of having the magnet wire for these repairs. A lot of people you see are using 30 gauge wire, but the insulation on 30 gauge wire is a lot thicker. This insulation on magnet wire is actually not any kind of you know, plastic or whatever. It's actually painted on. That's how, you know, that's how thin that stuff is. Anybody who does repairs like this on a regular basis on SMD boards should always have magnet wire for doing their. You've seen me use it on other videos. Anyway, so I just wanted to make that point. I'm going to continue on this, and I've only got a couple more to do, I think, before we're ready to do some testing, continuity testing, and plugging it in. Now again, these ones that are connected here, I'm not too worried about. I'm going to finish running bodge wires, and then I'm going to make sure that obviously these are not touching. I'll probably move them out of the way or put some Kapton tape underneath them or something. Make sure that they don't make contact when I flip the board over, because they might move to another pad, and that might be really bad if there's a pad next to it that's a VCC or something. So once I get all those done, I'm going to test it, and we're going to see if we get a working motherboard. If we don't, we're going to proceed on the troubleshooting as to why it's not working before we ever solder this connector back in. I don't want to do any major work on this board other than the repairs until we have a working board, and then I can add the connector and then test it again. So I'm just going to go through installing these bodge wires, identifying the problem, and then installing the bodge wire. So we have some sliced up area right here, and there's a couple broken traces, and one of them is going to this via right here. It's this one that comes up here. The one right next to it actually is good, but this one here isn't. So this one here goes up here, and it actually, if you follow it, it actually goes to right up here. And then from there, it continues on and goes somewhere else. And so I'm going to switch over here. Hold on. So here we have Amiga PCB Explorer. And I just went ahead and I just clicked right there at that via that we saw. The damage is right here, as you remember. So we can follow it up here. It's very nice because we don't have to follow it literally. We can just look at it on this diagram. And then it comes up to here, and that's what I just showed you on the motherboard. So we're going, and it continues on and goes to other places. So all we're concerned about, and it's actually labeled NTSC, so it must be a video signal of some kind. So what we're probably going to do, let's see, we have a pad here. In the previous one that I didn't have any pads on the reverse side of the board. One of them was on U2, and another one was a resistor, and but they were all on the top side of the board. So what I did was I simply made a connection between the vias, but on the back side of the board. So that's one technique. This one we have, we might be in the same situation because here we have a resistor on the top side of the board. If you hover over this, it tells you every place it goes to. So that resistor that we were just looking at, it has there's 3 resistors that it goes to, and then it goes to U2. So it's, yeah, right. It goes here to this chip right there. It goes underneath the board over to this resistor. You know, so because it's going all over the place, the best way to repair this would be to simply link those 2 vias together. Oh, first thing you want to do is we want to go to the bottom of the board, and again we still have it selected, and we can see the dashed line. So we're going to replace that dashed line with a bodge wire. I don't know if you can see that. It's very faint, but you can see the dashed blue line there. I'm going to have to take a closer look. But basically you follow the dashed line until you get to that via. It goes right to this link, this via right here, and it's conveniently located right next to C461, so that's easy to find. And then we'll go follow the dashed blue line. Again, it's dashed because it's indicating that it's on the other side of the board. And right there. So we're going to just use a hobby knife to scrape off just very lightly until the pad becomes shiny. Scrape off solder mask. You could use sandpaper or, you know, I guess a file, but you could probably use like an emery board, something that gives you precise control. But I'm just used to using my hobby knife. So anyway, okay, next step. So using that diagram, you can see that I have here's one that two that I've actually already done. I don't know if the shadows kind of makes it look like it's a mess, but I assure you it looks pretty good. Can I zoom into those? Pretty good, yeah. So you can see I've done 2 there. And so the next via is right below there. You've got a group of 4 for which those 2 are, and then you've got this group down here of 2, and then right below that, this one right here is the pad we want. So we're just going to do a little scrapey on that pad until it becomes a little more shiny. We're going to be very careful not to go too deep or dig into the trace that's running into it or anything like that. Just a little bit of flux. I wanted to get rid of that unintended solder blob, but here we have a nice, yeah. It's got most of the trace, or most of the via. So we just need to do that twice, and then we want to take our magnet wire and measure out an appropriate length for this. The one thing about the magnet wire is insulation. It is convenient that it is so thin, but it's also a little bit more difficult to strip it. You basically have to scrape it away. So we're going from there all the way up to right next to C461. So that's up here. That one already has. It already actually has some solder on it. It might have some solder mask over it also. So I'm just going to give it a little scrapey scrape. Just to make it shiny. Just enough to make it shiny. Just make sure that it's ready. Yeah, I think we're good there. So now that I have my 2 points, I'm just going to measure out a piece of magnet wire. Okay. Now we're just going to tin these and stick them on the board. Easy peasy. That's good. Okay, so this is the one right here. Yeah, you can see it's scratched up. Now we should have continuity. We didn't before. There. It's the solder mask. You do need to be aware. I mean, you saw me scraping the vias. The solder mask will also prevent you from getting continuity on a via as well. Usually the best thing to do is to sort of stick your probe in it and kind of rotate it a little bit until you break the thin layer of solder mask, I guess is the way to think about it. Anyway, so that's how I've been doing it, and I'm going to continue with that. I believe that might have been the last one, actually. Okay, moment of truth. We're trying it for the first time together. I have my my special power supply. I have another video on how I made this power supply. It's actually fused, so that will help if there's any problems. We're turned off and everything. Okay, video, power. I hooked up this so that I could see immediately if we have a light on. And here we go. 3, 2, 1. Okay, that's good. That's really good. Yep. Okay. So we have a working 1200 now. I just need to solder in the PCM CIA. Then we'll be we'll be back to normal. Okay, back on the workbench. Just make sure all the pins are straight here, and then make sure we have a good fit here and that we slide in okay. Yep, seems okay. Well, looks like I'm going to have to put pressure on it. Anyway, I definitely still need to push down when I do my first. I'm just going to grab this over here. Down plane. And I'm going to inspect it and make sure we're down on there pretty flat. It looks like we are, as flat as we're going to get. Since I made this diagram for the top of the board, I will simply look at it from the bottom through some light and use that to verify my connections, because I no longer have access to look at the top of the board. The connector's covering it now. Okay, so we've got the connector on there and we're still good to go. So now the trick is verifying that the PCMCIA slot works. Now Brad did leave me a card that has a storage. It has a compact flash adapter in it, and then he left me his bootable compact flash OS card. So I guess we're going to just try this, and hopefully, I guess I'm going to need a mouse too. So let me get some stuff together here. My friend left this with his compact flash to boot off of, and of course it doesn't work, probably because the accelerator isn't here. I did the stupid thing of telling him not to leave any of the peripherals, not realizing that it might cause a problem if I tried to boot his operating system without the accelerator, because apparently this just freezes. It doesn't boot, the computer just freezes on boot up. I took my Amiga 1200 out and grabbed its compact flash and installed it, and it boots just fine. The only problem being is that it's missing libraries or whatever. It's a 3.1 Workbench, vanilla Workbench install, and this is 3.2. And you know, as everybody knows, there's always going to be missing libraries and stuff like that. It's really annoying that way. I guess the PCMCIA card requires a driver, and here's a boot disk. The problem is I don't think this is going to work with 3.2 either. I bet this won't boot under Kickstart 3.2. Well, okay, so he was saying that perhaps he wasn't sure if these disks worked, and this one doesn't work. I mean, it is a boot disk. Okay, there we go. But it's going to fail on boot up, right? Because it's not going to have the right libraries? Maybe? Oh. Come on. It'll work. Okay. Oh. Yeah, this is where I would need a Workbench disk with 3.2. I'm just wondering if, yeah, so this isn't really going to work. I could put older, ROMs in. That would work. Of course, I'm going to have some older ROMs. So we got 3.1 and we got 3.0. You know, let's go ahead and just use these factory 3.0 ROMs. And okay, so those are 3.0 ROMs. I put the factory 3.0 ROMs in, and I'm going to plug a 3.1 Workbench disk in. I think it's going to work. Okay, so we're good there. So let's try to plug our PCMCIA card in there. Right. And the disk that we know works. And then it's going to ask for, here I'll show you. It's the PCMCIA boot disk from Amiga Kit, and it does boot. Then it doesn't actually boot into a workable Workbench. You have to insert a Workbench 3.1 disk. Okay, so it's asking for the Workbench disk. Hopefully the next button will degray itself. Okay, good. Please, I don't. Is it the original? Is it this disk again? Okay, well, I guess I got it. So that's what it was asking for. Is this our compact flash? Or is it the day? I think we might be okay here. Let's see. It already is. Yeah. Okay. This has got to be, yeah, this has got to be his stuff. It's weird the way it loads it into a list like that, huh? 2.637 gigs. Doesn't say what this card is on it, but I guess it's a 3 gig. Or no, it's a 4 gig. Yeah, okay. Because 11 is used. Okay. So yeah, that must be it because it's 4 gigs. All right, cool. So we have a working compact flash. So now we have a fixed Amiga 1200, and he wants me to do a mod to it. So I'm not sure if I'll do another video, but let me cut the video here, and yeah, I probably will do another video. Separate subject, separate video. So he wants me to add something to the motherboard, so we'll do that on the next video.